Hello. Today we're going to go through Learning Target 5.2.3, which is factoring quadratic functions when a equals 1. And we are using factoring as a process to find the x-intercepts of that quadratic. This is just an alternate method to the quadratic formula, and factoring ends up being easier and faster for us in specific circumstances. So for certain quadratics, this process will be faster and easier. But if this doesn't work, or if this ends up being longer, the quadratic formula always works. So if you could go ahead and pause this video and write down these steps. We're going to need these at the top of your paper, and then I'll go through each of them and talk through them as I go through an example. But right now, pause it and write down all of these steps. Now that we have those written, we are going to go through an example. And actually, the beginning part of this, steps 2 through 5, we've done before. We did this last unit when we were talking about greatest common factor. We used our t-chart and we found our factors, and then we wrote our answer like this. Today we're just going to go one step further and use that process of factoring to actually solve for the x-intercept, so using it for a purpose. So our first example says solve the quadratic to find the roots. And find the roots or find the x-intercepts, remember those are all the same word. So if you want to kind of make a little note to yourself, roots means x-intercepts. They're also the same as zeros or solutions. So if you're asked for any of those things, you are going to factor or use the quadratic formula to solve. So our first step is to make sure the quadratic is on the same side and equal to 0. So if we look here, our quadratic is all on the same side, and it's equal to this f of x. Don't let f of x throw you off. This is just another way to say y. So y equals this stuff. And we want to change that to a 0 because we're going to set this equal to 0. We want to know where the zeros are, so we set this equal to 0. And you can see my whole quadratic is all on the same side of the equal sign. It's all on the right-hand side, and then on the left is just 0. So step 1 is done. Check. Step 2 is to factor out the GCF. So I want to factor out if I have any greatest common factor. And I need to look at all 3 of these coefficients. So 3, 3, and 18. And remember, we can make our little factor trees for all of them if you wanted, but you really only need to make the factor tree for the smallest of the numbers because you can't have a GCF bigger than 3 because you cannot divide 3 by anything bigger than 3. And so 3 only has factors of 1 and 3, so I just want to check to see if everything can be divided by 3. 3 divided by 3 works, 3 divided by 3 works, 18 divided by 3 works. So this is my GCF. And I want to make a little note to myself when we factor out the GCF. If A, which is the first coefficient, is negative, we pull out the negative. So if A is negative, then we pull out the negative. And in our case, you can see that A is, in fact, negative. So when I go to factor out the 3, I want to take out a negative 3. And all that means is that I am going to divide everything by negative 3. And so I get negative 3 divided by negative 3 is just 1, so I get x squared. 3 divided by negative 3 is negative 1, or negative x. And 18 divided by negative 3 is negative 6. So I got rid of my GCF. And I should have my GCF out front. I kind of forgot about it, so let's write that right now. Because I don't want to forget that I took that out. I just don't want it in there. So now I need to identify my A, B, and C for the leftover quadratic. So this part right here, I need to identify A, B, and C. So I'd highly recommend writing them off to the side, like we did with the quadratic formula. So our A value comes in front of the squared term, so that's a 1. Our B value in front of the x term, so that's -1. And our C value is our constant, just our number, which is -6. And now we're going to use our t-chart to find the factors that multiply to C and add to B. So remember, we draw our little t, and over here I want the numbers that multiply to C, and over here add to B. So my C value is -6, so I want the numbers that multiply to -6, and my B value is -1, I want the numbers that add to -1. So a calculator is going to come in handy to get all of our factors, and remember our process was just to divide by 1, then divide by 2, then divide by 3. So -6 divided by 1 is -6, so we have 1 and -6, but then remember for every pair I need a duplicate. So this one has a +1 and a -6. Now I need to flip the signs to give me a -1 and a +6. Then -6 divided by 2 is -3, so +2 and -3, and then -2 and +3. And then the next number I was about to type in is 3, but I already have it written down, so these are all of the things that multiply to -6. Now I need to figure out which of these pairs adds up to -1, and there is only one pair that does that. So if I add these together, I get -5, that's not it. If I add these together, I get +5. If I add these ones together, I get -1. Which I think is what I want, and it is. So I do want a -1. So these are the factors that I want. And so now I'm going to write it in factored form like this, with the GCF out front and then x plus or minus my 2 factors. So I have my GCF, my -3 out front, and then x plus 2, because it's a +2, and x minus 3. And so all of this was a review from last unit where we did this t-chart, we found our factors, and then this is where we used to stop. But now we just have one more step. We're going to set each factor equal to 0 and solve. If these are being multiplied and they equal 0, then we know that one of them must be 0. And we're trying to figure out where our x intercepts, where our zeros are. So you split this into 2 pieces. This first factor equals 0, so x plus 2 equals 0. And this second factor equals 0. And then we just need to solve and write it as a coordinate point. So they usually are just one-step equations where I just need to subtract 2 from both sides and I get -2. Writing that as a point is -2, 0. For this one I add 3 to both sides and I get x equals 3, and writing that as a point is 3, 0. And so here are my 2 solutions, my 2 x-intercepts for my quadratic. So now I do want to do one more. I know this video is a little bit longer than normal, but factoring just has quite a bit of steps at first. So let's look at this second example, and I'm going to have you try most of it, but I'm going to start it for you. It says, which of the following correctly names the x-intercepts of the function? So step 1 is to make sure that all of the quadratic is on the same side, but you can see like this 5 is on the other side. It needs to be over here with us, and it's not. So I'm going to subtract 5 from both sides to get rid of this. So then I end up with n squared plus 7n plus 10 equals 0. And now everything's on the same side and it's equal to 0, which is what I want. So if there's ever anything on the other side, you have to move it first before you get started. You cannot factor just this part and pretend the 5 doesn't exist. You have to get it over on the other side so that you can simplify. Then you want to find the GCF, but you can see this is just a 1, so there is no GCF, or the GCF is just 1. So we don't need to factor anything out of this problem. We can simply skip to finding our A, B, and C, and then making our T-chart to find our factors. So I want you to pause it right now and get through and see which answer you think it is. I'm going to write all of my work, so when you unpause it, you can see it, and we'll talk through the answer. So I labeled my A, B, and C. A is 1, B is 7, C is 10. And then I filled out my T-chart. Remember, we need 2 pairs, so I have positive 1 and positive 10, but then also negative 1 and negative 10, and the same thing for 2 and 5. So the pair that multiplies to positive 10 and adds to positive 7 is 2 and 5, so I wrote my factors like this. So n plus 2, n plus 5 equals 0. Now I'm just going to split these into 2 parts and set them equal to 0. So n plus 2 equals 0, and n plus 5 equals 0. And then I subtract 2 from both sides to get n equals negative 2. Subtract 5 from both sides to get n equals negative 5. And these are my 2 factors. So if I look up here, I can see that is answer option B. Answer option B. So you can see how this process is probably faster than typing all this into the quadratic formula. If you can find those numbers pretty quickly, you can save a lot of time by doing the factoring method. But again, at the end of the day, the quadratic formula always works. So if you can get good at that and use that, that works as well.